Okay, this is my recording describing the performance of my lane detection algorithm. So for the most part, I've kept a lot of things the same from the code described in class regarding snipping images, masking it, all that good stuff. I filled around with these parameters a little bit, but nothing too drastic, just making it fit a little bit better with the videos provided. Past that, the thresh image is very similar as well. I changed around the threshold a little bit, but I'll explain that later. And then blur, edge, and lined are all very similar. I stuck with 20 here. It seemed to work out best. Okay, and then essentially I'll get to all this in a second. In my main, I implemented a very similar way, and the way I iterate through them pretty much is frame by frame by a key press. So if I just hold down a button, it will stream the video. And then that calls this process function, which will take one single frame and then apply all of our different image changes to it. That's the mask, the threshing of it, blurring it, using the edge detection, and then I create the array of lines using the ho lines. Not exactly sure how you pronounce it. Following that, I have a couple things defined up here. These will store points in the case that maybe one of the lane edges isn't detected. You're still able to redraw the last detected thing, and that works out pretty well. Moving on, I have opacity defined here. That's because I've created the lane lines with opaque or semi-opaque different colored lines, and so this is just a variable you can change around, as well as foo and bar I had in for testing purposes, specifically with creating the length of the lines. Cool. So for the most part, what goes on here is I initialize a couple parameters or variables, all to 0. These are essentially just counters to separate out and distinguish between the left and right lane. The way I do that is iterating across the lines, all of them. You find the row and theta of each one, and I personally chose a theta value of around 1.5. I found if the theta value was less than that, it was in the left lane, and if it was greater than that, it was in the right lane. And as far as the videos, it worked out really well. So essentially, I split it up here. If it's less than, I add the row to the total value on the left. Same with the theta, as well as increment a counter. Same process for the right. Then this is an if statement, simply to check if there were any left-sided lane, like if a left lane was detected. So if there were any left-sided lines, then I bring in these global points, and I go through the process of calculating theta row. This is just the averages. I take the mean. Same process for creating A, B, X naught, and Y naught, as well as for creating point 1 and point 2. I use the foo and bar here. This is where I was messing around with those parameters. Then onto here, I have the left point gets set to the global variable. So it basically stores it. So in the case that no left lane is detected, it can still be brought in for the next frame. Then I use this overlay, like I create a copy and overlay it with this cv2.addWeighted function. This essentially just, you define an opacity, an alpha and a beta, and it will overlay an opaque line on the image. Then in the case that no left lines are detected, this is this else statement, we go into here and we repeat the same process, but we don't calculate any new lines. We use the ones stored right here. Then essentially we repeat this process fully for the right. Same exact thing, but just looking at the right thetas and right rows. Go through, create your points, store them in the global variables, create an overlay to create opaque lines. Then this is a special edge case. Essentially, we have the check up here which is the if lines is not none. And so in the case that lines is none, say it couldn't detect a right or left lane, this is a special edge case where we put on the last reading of the right and left lanes. Then I show that, and I'll give it a shot. This is for the first test. As you can see, it's a little wonky just to start off, but as soon as the first lane merge is finished, it picks up on them pretty quickly. Then, especially if you keep your eye on the threshold and line images, works out pretty well. I've run through this whole thing. No major errors or anything like that, except that very small beginning part. I think just right when you're crossing over a lane line, it has some trouble. But in terms of lane detection, you just want to be sensing them when you're in, so I don't think that's too much of an issue. I can show you more of this, but this one actually worked out pretty well. Moving on to the second video, I did have a bit of an issue with this one in that, and I'll show you here, first off, it starts off very bright, but if you run it with a similar threshold value, it can't pick up on anything because of the increased brightness of the scene. And so to fix that, back in the thresh image function, I simply change the threshold value up to 150, and that seems to work out very well. I can show you. After the initial glare, it picks up on the lines pretty quickly and then moves with them. And you'll see in the lane transition coming up that also gets handled pretty well. Overall, I think I could definitely improve. Yeah, so here's the lane transition. It loses that center lane marking, picks it up as a left lane in a rather not a particularly great way, but then very quickly as it enters its new lane, picks up on the left lane again. Same thing, tracks across that. You can see times when the left or right are kind of stagnant and not changing, and that's when it wasn't able to pick up a left or right lane. You'll also see it a lot when the shadow of a car, such as is coming up right now, passes on the lane lines. If you see the left one's stagnant for quite some time. I don't have a great workaround for this, as it's quite hard to get something that works across that level of like a line in shadow pretty much. If you see here, the on the right side, the edges are being picked up of this kind of lane transition or traffic hazard thing, and that kind of wobbles the right lane a good amount, especially because those are a lot brighter than the actual right lane itself. But pretty quickly after that, it picks right back up, and it keeps the lane detection to where the car should be, so it's still not too major of an issue. In general, I think I was looking into some ways to try to get this threshold to be done automatically, so it could be done for any lighting conditions. And my ideas with that were involving taking the average brightness of the scene and trying to do something like that. But any methods I was looking into online of doing that were a little like, I'm sure they would have worked, but they were more complicated than I was ready to be able to explain in the video. So I figured I'd keep it simple and just keep to an explanation I can handle. But yeah, other than that, an additional way I could upgrade this is I kind of just messed around by hand with exactly how long I wanted those lines to be. I think I was dwelling on it for a little while, but couldn't think of a great solution to create, like, so that they go a set distance into the screen, similar to how yours look, where they're very, very robust and standard. As well as I started looking into creating that opaque overlay between the lane lines, and just didn't get too far on that, and then realized they weren't required. But yeah, that's my lane detection algorithm, and I think it works pretty well. Thank you for your time.